Hi there, everybody. Welcome back. This is lesson 4 in our Unit 3 bonding, and today's lesson is called Naming and Formula Writing of Binary Compounds with Multiple Oxidation States. So in the last video, we talked about basic naming of ionic compounds, took the metal, named it, gave the nonmetal with the IDE ending. That was it. But when we talked about stuff here, the metals had one oxidation state. And so what I mean by that, if we look at, Na, for example, there is only one number in that top right corner. But today, we're going to talk about how to name things that have multiple oxidation states. So, for example, if we have iron, which is Fe, it has, a +2 and a +3 charge. Our job today is to figure out, well, how do we know which one we have to use? Okay, so kind of a background, transition metals and their positive ions. So a lot of these transition metals, remember transition metals are that middle section of the periodic table, groups 3 through 12. Now a lot of them you'll notice have multiple oxidation states or multiple positive numbers in that top right corner. This picture shows a few of them. There are more on the periodic table, but some of them do only have one state. So you have to check to make sure if it has multiple states or not. And so if it does, we have to give it a name. So if we have chromium, for example, there is a +2 version of it, and there is a +3 version of it. And I'll show you guys how to kind of figure out which one it is. But you also have to name it. You can't just say, oh, I have chromium in my compound. You have to say which one. And so that's where these Roman numerals come from. So if you think about it, you have a class of people. There's a bunch of people. And let's say this person's name is Jennifer, and this person's name is Jennifer. And I say, oh, hey, Jen, come here, I have to talk to you. These Jennifers, they don't know which one I'm talking to. But if I say, hey, Jen J, come over and I have to talk to you, then she knows I'm talking to her. Or I say, hey, Jen R, then that Jennifer knows that I'm talking to her. So just like if we have two Jens, now we have to use their last initial. Same thing with these elements. So if I have chromium in my compound, I have to say, well, is it chromium 2 or is it chromium 3? So these Roman numerals act like last names for these elements. So again, if I say, oh, I have iron I have iron in my compound. Well, is it iron with a +2 charge or is it iron with a +3 charge? If you just say iron, you don't know. But if I say, oh, iron 2, that means I have the +2 charge. If I say iron 3, it means I have the +3 charge. So that's just like a last name. So let's keep going. Okay, before we get farther into this, let's take a quick review on Roman numerals. So I is 1, I is 2, I is 3, IV is 4, V is 5. Now, you're not going to use all of these numbers, but these are the numbers up to 10. VI is 6, VII is 7, VIII is 8, IX is 9, and X is 10. So you'll see most of these in these names. That is what this is. Okay. So I'm just going to leave this here for a second. Absorb it. Okay. So here are these steps, and we're going to work through these together. I've had to name something with multiple oxidation states. So your first step is to determine whether or not the metal has multiple oxidation states. Is it a transition metal with multiple options? If it is, well, then you got to figure out which charge you're using. And to do that, you have to use the nonmetal. And then once you figure that out, then you have to use the charge with the Roman numeral, and then you write the IDE ending. So again, this doesn't make much sense. Let's go ahead and do an example of this. So I gave you the formula FeCl2. So I went ahead and pulled up the reference table and looked at iron. So iron has a +2 charge and a +3 charge. Our job is to figure out which one of those is in our compound. And so what you need to remember is that compounds have an overall charge of 0. So compounds are neutral. So what you want to do, we have this formula. So if we know we have Fe, so let's make Fe blue, and let's make Cl green. So with Fe in our formula, we have one of them. And now we don't know what that charge is, so let's make that X. And we know we have 2 chlorines in our formula, and our charge for chlorine is -1. Just to recap, for nonmetals, use the top number only. So chlorine has a few options, I believe, but for nonmetals, you're only using that top number. Okay, so if we go ahead and kind of bring this down a little bit. Oh, and we know this needs to equal 0 because compounds have an overall neutral charge. So 1 times x is 1x plus 2 times -1 is -1 equals 0. So how do we get x by itself? Add 2 to both sides. 1x equals 2. You can even just say 2. Again, divide both sides by 1. X equals +2. So what that tells us is that we're going to use the +2 version of iron. So now when we go to name that, we have to say iron 2. So again, we can't just say iron because we have those two options. We have to say iron 2, and we know it's 2 because we solved for it because we know the compound is neutral. And then you name Cl like we did before, chloride. So that nonmetal with the IDE ending. And that is it. Okay, so let's try another example. So now we have Cr2O3. We want to figure out what its name is. Now, Cr is chromium, but we can't just say chromium because it has multiple different versions of it. A +2 version, a +3 version, and a +6 version. So we have to figure out which one of those versions we're using. So what is the last name of chromium? So we can figure that out because we know that the compound overall has a neutral or 0 charge. So the total plus stuff equals the total negative stuff. And we always know the negative stuff, so we can use that to find the positive stuff. So in here, our formula says we have 2 chromiums. Now, we don't know which option that we're choosing from, so we're just going to leave that as X. We're going to plus, and we know it's going to equal 0. And then, if we look at oxygens, we have 3 oxygens. So that's where that comes from. And oxygen, we know, has a -2 charge. Again, when you're dealing with nonmetals, you are only using the top number for nonmetals only. Okay? So, if we go ahead and bring this down, 2 times x is 2x, plus 3 times -2 is -6 equals 0. So if we neaten this up a bit, 2x minus 6 equals 0. So how do we get x by itself? Add 6 to both sides, get 2x equals 6. Well, how to get x by itself? Divide by 2, divide by 2. X equals 3. Again, it's that +3. So now we know we're using chromium plus 3. So what you do now is just write chromium. Now that we know which one we're using, we're going to use that Roman numeral 3. And then the way we name oxygen is oxide. And that is it. Okay, so let's try this one. Let's see if you guys can do this more on your own. So again, we have Cu2O. We have to figure out which copper option that we're using. So again, I'll help start you off. We have Cu and we have O. And so we have two coppers. We don't know which charge we're using. We have one oxygen, and we know it's -2. And what we know about compounds, if we add the positive and the negative, it should give us 0. So with that, go ahead and figure out what the charge of copper should be. So if you did that, you should have been 2x plus -2 equals 0. If you neaten it up a bit, 2x minus 2 equals 0. 2 plus 2 on both sides. 2x equals 2. 5 by 2, x equals 1. So that tells us we're using that +1 option. So now, what is the name of this? And so again, you should say copper, and we have to give it its last initial, so that charge +1, and remember O is oxide, so this would be copper 1 oxide. And so again, here are the directions that we followed. Figure out if we have a transition metal and if that transition metal has multiple oxidation states. And then if it does, we're not going to freak out and panic. We're just going to do a little bit of math. And since we know the overall compound is neutral or has a neutral or a 0 charge, the plus stuff equals the minus stuff. And for nonmetals, you always know what the negative stuff will be because even if it has multiple options, nonmetals, you're always using that top number. And you can use that to figure out the positive. And then once you have all of that, then you can go ahead and finish naming it and using that Roman numeral to tell you what charge that we used. Okay. Okay, so now we're gonna go backwards. I'm going to give you the name. Your job is to figure out what the compound is. So this is a bit easier. So again, here are the rules. Write down the symbols, figure out what that Roman numeral means, do the crisscross method, simplify, write the final formula. Again, this might not make much sense yet. Let's go ahead and apply these rules. So we have titanium 3 phosphide. Titanium 3 phosphide. So your first step is to figure out the symbols of each thing. Titanium is Ti, and phosphorus is P. So for titanium, we have this Roman numeral 3, and again, we know that means we're using titanium plus 3. Now, it doesn't matter that it has multiple options. We know it has multiple different versions of it because the Roman numeral is there, but we don't even need to look at it because the Roman numeral 3 means we're dealing with a +3 charge. Phosphorus, we know, has a -3 charge. Again, for nonmetals, you're using that top number only. So then what you do is like what we did before, crisscross, crisscross. So you get T, use different colors, Ti with that little 3 that came down from phosphorus, and you have, still using orange, phosphorus with that little 3 that came down from titanium. But remember, you want to simplify. So both those things are divisible by 3. When you simplify, you get TiP, and that is it. So let's try another one. Here we have tin 4 oxide. So what does this Roman numeral 4 mean? That means we're using a +4 charge on tin. So tin is Sn. Again, if you forget that, table S has all the names on it. And then oxygen is O, and we know it's -2. So again, what you're going to do is crisscross and take those numbers only. So you get SN with that 2 from oxygen. You get O with that 4 from tin. Now, you have to simplify that compound because both of them are divisible by 2. When you simplify, you get SnO2, and that is your compound. Okay, so let's do one more. Now we have nickel 2 fluoride. So, nickel is Ni. What does that Roman numeral 2 mean? You should say it's that +2 on nickel. And again, we know chlorine is Cl with a -1 charge. So again, nonmetals, you're always using that top number, even if there are multiple versions of it. So then you take that number, cross it down, take that number, cross it down. You get Mi with a little subscript 1 from chlorine. And then you get Cl with the subscript 2 from nickel. Again, if you have 1 in your formula, you don't need it. So you can simplify that to NiCl2. And that is it. Okay. So with that, here are the rules again. Again, figuring out the symbol of each element. If you have that Roman numeral, it tells you what that charge is. Again, you only have the Roman numeral if your metal has multiple options. And then crisscross, get your formula, and simplify it. You're going to practice this more in class, so do not worry if you are a little bit confused. On the next video, we're going to cover how to draw dot structures for these ionic compounds. So this gives us another chance to kind of revisit naming, and now that we have a name of it and a formula for a compound, we're going to figure out what it actually looks like. So we're going to use what we learned about these dot structures for atoms and ions and use them to form these ionic compounds. So that is it for this video. Have a wonderful day. Bye.